Hey everyone, it's Daniel from JustPaid. I wanted to show you guys a conversation that I had with one of the engineers on some of the technology that we're using to build JustPaid with AI. We're using things like LangChain and LangGraph, which are super new technologies to basically understand how to extract information from a lot of these complex contracts that we have. So super excited, stay tuned and you'll learn a lot about AI in this conversation. So what is LangChain is lower level and you can have many chains, or is this wrong?
No,
LangGraph
yeah,
LangGraph is on top of it and it orchestrates where to go. So if there's a specific workflow or something, LangGraph will direct and pick a chain possibly. Is that right?
exactly. Yeah, that's right.
That's right. Okay, so that's the difference between LangChain and LangGraph. So that right? So
Yeah,
like a LangChain could be like if it whatever if AI wants to use a do math, the chain will like be a math guess, and LangGraph will say, hey, this is math. This chain is good at math. Or if this is like a visual chain, it would default to a visual chain. Or if it's like a question, it knows that this chain would be better for a question. Something else, it could default to that. So LangGraph is kind of a router. Is that right? Or no?
it can be seen as a router. I mean, it's technically more than a router because what allows LangGraph is to have different instances of an AI model inside each node. So, and at the end, this ability to choose a path and choose the better path for something and have just the fact that we have a path for one feature and another path for another feature, that ability to choose a path and that ways, that's an agent.
Yeah, I see.
And that's the main point of LangGraph, create agents.
So really, LangGraph is an agent creator. And then what
Yeah.
you're saying is this is very hard coded. It doesn't change, right? Like coded, and but there's all different type of LLMs, right? These are different. But this guy is literally like making decisions almost like an agent. An LLM, they're just different. It's like a whatever else you have in there. So what we're doing, our goal is to create a agent that will help parse documents. Is that right?
Exactly. Yeah.
So, what would be an example of line graph parsing and jumping between this chain and this chain?
So we have an initial node. It's inside LangGraph. We have an initial node of classifying the document. We need to classify it into purchase order, contract, amendment, email, etc.
Yeah,
And we need to be able to tell if that document can possibly or well have all the elements required to be a contract. So first step is okay, classify this into a purchase order or a contract, etc. And then if it is a contract, then we go through this path and we say, okay, it is a new or amendment. If it is not a contract, let's say it's a purchase order, it goes to the parsing node. So that's the flow.
I see. So,
Then
line graph is figuring out what to first do. Is it a PO, purchase order? Is it a contract?
yeah, I mean,
It,
a simple way to see it is LangGraph provides all the infrastructure, but at the end, all the decisions are made but by an LLM.
got it.
So in reality, we have a graph that is connected and has all the steps that we want to follow, but in each one of those nodes, there is an LLM, and the LLM is the one that says like, okay, this seems like a purchase order, and then like, okay, this or maybe this seems as a contract and then, okay, this seems as a new contract. That's an LLM. And LangGraph provides all the infrastructure to connect all of that nodes.
This is a node. These are nodes, or
Yeah, yeah, totally.
okay. Are they all have their own different LLMs, or maybe the same LLM? It's just different flow, I guess, like a different processing.
Yeah, they're different.
I mean, I kind of view these as like factories. Like this creates a Ford car. This creates a Tesla. This creates a Chevy. This creates a Toyota. Like they're just different.
Yeah,
But what does this do for that? This person wants a Toyota, so they have to go here. Is that right?
no, that's right. That's right.
So this is literally a thinking, it thinks.
It decides. It decides based on the information given. I wouldn't say it thinks because let's say like the reasoning, the capability of reasoning is not like really defined right now into the LLMs, but it decides. It decides which is the correct path to follow based on the information given. So maybe the best way to put this is like, I don't know, maybe Toyota is worldwide known because it has like really reliable pickups and etc. So maybe the input is like, okay, there is a user, the user, I don't know, has a farm, the user likes like the diesel vehicles, and the user needs the vehicle in order to transport a heavy uh, products inside their farm. And then based on that data, the agent is saying like, okay, based on that, it is more probable that he wants a Toyota. So go to Toyota.
Got it. So it's almost a statistical understanding thing that can route to different other chains.
Yeah,
Okay.
exactly. Yeah, and at the end, AI is just statistical, it's really fancy statistical stuff.
Is LangGraph considered the agent? Is that why people? So this is an agent, right? So this is the actual. It says it's a feature,
Yeah, all
right?
of this flow, like the LangGraph and LangChain and LLMs, all of this together, that's the agent.
All this together is an agent.
Exactly, that's
Okay,
an agent.
I see. And then these could be like OpenAI, Anthropic. I mean, we're using what we're using, but it could be like OpenAI, AI. This could be Anthropic. So we could be a hybrid. We could build a hybrid,
Yep,
right? So there's just hybrid approach, and then maybe there's others like DeepSeek. I'm just using
exactly.
examples. So we could have like a really good, very, very
Yeah, exactly.
robust. It's robust, is what I'm saying, is because then you have lots of options to parse things correctly. Got it. Okay.
And yeah, exactly. And basically, all of this that we have here is a flow, paths. And main
Paths.
difference in graph is that LangChain is designed for linear paths. LangGraph is designed for this kind of paths where we can choose which step to follow, like non-linear graphs, non-linear flows.
Yeah. So like there's no option. It's just you're going to use this LLM no matter what. Like with this, you're just going to,
Exactly.
it's a line essentially. You're going to use this no matter what. You're going to be using
Exactly.
this path no matter what. But this guy, since he's layered on top, is multipath. So he can go many different ways like that. So he's basically layered on top. But there is no LangGraph without LangChain, right? So you have to have
Yep.
LangChain for LangGraph. So this doesn't exist without all these.
Yeah.
Okay.
Yeah, it's basically a matter of inheritance. I mean, first one was LangChain, like a couple of years ago now. Then on top of LangChain, they built LangGraph.
And is LangGraph, how new is LangGraph?
Well, I know until end of the past year they were on beta.
Oh, until
So,
last year. Okay. So LangGraph is very, very new. It's new stuff.
but yeah, this agentic approach for the AI, it's really new. It's like the thing that is gonna be increasing in the following years.
And it's very similar to the brain now that I'm understanding it. So, like, your brain is a graph. If you're going to be doing something logical, you're going to go here. If you're going to do something that has to do with creativity, you're going to go here. If you need to breathe or do something like that keeps you alive, you're going to go here. Different parts of the brain. So they're kind of building concepts depending. Maybe that's the wrong approach. It's more like data comes into LangGraph. LangGraph like routes data. It's not quite the brain, I think. It's more a brain, all of it exists at the same time. It's
Yeah.
more LangGraph is more here's some LangGraph, make a decision on where it should go, what, and then it brings in OpenAI and whatever else like that needs to happen. Now, where does the memory come from with LangGraph? Like, is that just a database? Like, how does it remember? Because LLMs don't remember. Like, are you feeding in the data with the
Yeah, that's
contract?
correct. So there is the definition. We have two kinds of memory here. We have like the memory for one connection of the graph of the agent. So for example, let's say the LLM OpenAI step and the LLM Anthropic step that you have right there. like calculate the difference between two dates. I don't know, it's an example. So the memory for the OpenAI to the Anthropic chain is something called state. A state is basically a structure that you define, and it's empty when the agent starts, and you are putting information as you go through the. So the state it starts in this case with a date that is empty. Then we go to OpenAI, we fill that date. Then we go to Anthropic, we fill another date, or we calculate the necessary thing, and that's the way we propagate information through the agent. So that's the first kind of memory, memory inside the agent, and it's called the state. And there's a second type of memory that's memory between two calls of the agent. So maybe if I want to remember something for the previous call, that memory it's inside the database, or the company database should be. We are not implementing that kind of memory right now, mainly because we want that the information of a previous parsing doesn't interfere into a new parsing in a contract. Why? Because with that kind of memory, well, you can, of course, have a better context, but you also can have bias. So, for example, for some reason, you have a company called ABC, you made a call to LangGraph, I don't know, a week ago, and then you make a call to parse a contract from XYZ. So, if we implement that kind of memory, uh, and if it is bad implemented, we can bias the XYZ parsing with the ABC information. So we don't want any of that right now. There is the two type of memory that an agent can have.
Sorry, there's two types of memory, meaning
Like memory inside of the agent
so like
and memory
OpenAI.
between calls.
Like OpenAI has its own memory right now, which is really the statistics in it.
Like we have like let's think about OpenAI, Anthropic, and DeepSeek as three steps. Each
Okay.
step depends on the information that the previous step has.
Yes.
So the inside memory of the agent is basically a form that we are filling. So we go to OpenAI, we fill some fields of that form. Then we go to Anthropic, we fill another information. Then we go to DeepSeek, we fill another information. And all of that field information is what we return to the user. And that's all. But that is just one call of the agent, like for parsing one contract or for just make one flow of information. So when when new information goes through the agent, it's the same principle. Like we have empty format, we go through each step and we are filling that memory and we return it to the user. The other kind of memory is that, for example, I made a call 2 weeks ago and there is like all this field information, and I use all that field information in order to make in order to fill another information. That's the difference. Like how are we filling the information through each step, and how the nodes communicate with each other, and then how do we communicate previous calls to the agent with newer ones. That's the difference between them.
So you can communicate, like, or no?
Kinda, yeah. Well, they don't like communicate in the strict meaning of the word. They just take as an input the state that I was talking you about.
Like this, LangGraph
And
will take this data. So it's like taking a contract or a PO or something. Let me just copy this and I'll just, like, there you go. So it'll say like PO contract, and then it has logic. It does something here, statistical logic it's doing. Is it taking anything else? Like history, or no? There's no history or memory like that.
in this case, no.
Okay. So we're just doing a
No, in this
one.
case, for example, what we are doing is that the main thing for the agent is the contract text.
Yeah.
And that's the initial state of our agent. A contract text with possible information. So that state includes a document text, a document type that should be like contract, PO, etc.
Yep.
Then a contract type, first result, well, all the information we want. All of this information, except the document text, is empty.
Starts
All of
off
this.
empty. Yeah. Yep.
Yeah. And we start the agent, and through each of one steps, we fill that information. So for example, in this case, in order to make sure we have the right information, I mean, for the contract validation node, we need the information itself. And what's an agent? The union of this little node. So what's happening inside each one of these nodes, there is an LLM call.
Hmm.
So inside this classified document node, we are calling Anthropic, like, okay, we have this raw document text. Please tell me if it is a contract, if it is a purchase order, or it is something more, and give me the reason why why you believe, why you think this is that particular file.
Yeah.
Then, and this node is, let's say, it identifies as a contract. So we go to classify contract. Inside classify contract, we make another LLM call saying like, okay, we have this document. We know it's a contract, but based on all the information, tell me if it is new or maybe it is an amendment. And okay, that step fills this information right here. Then let's say it's a new contract. So as it is a new contract, then we're going to parse all the information so we can jump from here to here. And we go to the parse node. This parse node fills this parse result with all the previous information. And then we have another node right here that is like parse line items. These parse line items fills this information. And yeah, basically that is how information is filled through the node.
Got it. So there are loopbacks. It does go back. So you have a different flow.
Yeah, exactly. What is happening right now is that after this parse node, we go through a node called a contract validation node. In that node, we ask an LLM call to say like, okay, we have this contract text and we have this extracted information. So compare it and tell us if it is right or if it is wrong. And then once we are sure that it is right, then we go to the line items parsing node, and the principle is the same. Like we extract the line items, then we go through another node called like parse like line items validation, and we ask an LLM like we have this contract, we have these extracted line items, are they correct or they are wrong or what's bad? Then we validate if the amount on the line items is equal to the contract, the amount of the contract, and if it is equal, then okay, that's good. If it is not equal, then we ask the LLM. Where? Well, an LLM again, like, okay, we have this contract text, we have this extracted amount, and we have this calculated amount. Why does they differ? Maybe it is a problem with the contract, or it is a problem with extraction. What do you think? And the other, like an opinion, like, okay, based on the information, I think maybe it went wrong. So if it is a parsing error, then we go again and parse the information. And then we ask again. And the LLM also can say, it's like, okay, no, it seems like it is more a contract error. Maybe they adjusted bad the frequencies, or maybe they made a typo. Something can happen. If that's the case, then we give a reason. Like, okay, it seems like you have an error on the contract, so please just make sure, or like, please review this section. And that's it. The utility of this is that we have all of these complex like reiterations and change between nodes. That's the difference between LangGraph and LangSmith, and that's at the end what an agent is. A connection of really complex nonlinear nodes.
Got it. Got it. Makes a lot of sense. I think I understand it a lot more. A lot more. And then each one of these, does it all have its own RAG? Like, do they all have their own RAG or no?
They have their own LM call. It is not a RAG.
Okay.
We are not using a RAG here.
Okay.
Because our context window is enough wider to like just give all the contract as information. The RAG systems are really useful, but are useful when we have a lot of data. So, for example, I know 500 documents,
I see.
each one with 20 pages or something. That is when a RAG it's useful.
Okay. Ours is small, less complex. Okay. Okay. Awesome. Sebastian, thank you for like walking me through this also. It's really, really good.